Now we are going to look at some basic concepts in thermodynamics. This is necessary so that we know what we mean. There are a number of terms which are used in thermodynamics which we also use in other parts of our life. One such very common word is a system. We are going to define now what we mean by a thermodynamic system. The word system is such a common word in English that it is used under various conditions. For example, we have a system of equations. We have solved a linear algebraic system of equations in high school. We have political systems, we have economic systems, we have social systems, we have family systems and what you have. So in computer science we have operating systems. But now we are going to look at thermodynamic systems, and in this course the word thermodynamic system will turn up so often that the initial part thermodynamics may often be neglected and we may just say system. So in this course whenever we say system, remember that what we mean is thermodynamic system. In fact, this is going to happen quite often. When we talk about thermodynamic system, we will shorten it to system. We will talk about thermodynamic interactions, we will simply say interactions, because otherwise every time we will be using the word thermodynamics perhaps too often. It is just not worth doing that. Now what is a system, or what is a thermodynamic system? For us, a thermodynamic system is essentially a region of space bounded by or with well defined boundaries. Boundary or boundaries, singular or plural, is left to us. This boundaries is important because a system in general representation would be a region of space, and the boundary may be defined as this boundary, or sometimes to emphasize that this is the boundary we align it or overlay it with dashed lines. We will see illustrations of real life thermodynamic systems later, but in general we would say that some region of space with well defined boundaries. Now when we say well defined boundaries, remember that these boundaries may be real, as in case of a surface, or they could be defined geometrically. They could be rigid, they could be flexible. Take for example this bottle contains water, of course some water and air. So I could say that look, whatever is inside this bottle is my thermodynamic system. So the contents of the bottle, water and air, are part of my system, and what are the boundaries? The inner surface of the bottle, it is geometrically defined. There is some crooked thing, but we would say that in spite of the complexities of the surfaces at the bottom, sides and near the top, we will say it is roughly a cylinder, maybe a narrowing portion on the top and with a cap closing it. So whatever is the inner surface of this bottle are the boundaries of my system. Whatever is inside are the contents of my system. Okay. In this particular case, the boundaries are physically defined. You can see those boundaries, and if you want to feel those boundaries, you can put your finger in and see that this is the boundary, this is the boundary. This inner surface of the cap, when it is fitted there, is also a boundary. But I can define a different system saying that look, the contents of this bottle without the cap, the boundaries are the inner surface of this bottle, and the closing boundary is the top surface of this bottle. Now there is no surface here, I can put my finger through it, but you can imagine a closing surface out there at the opening of this bottle. So this is a boundary, illustration of a boundary which is defined geometrically. There is a circular edge here, cover that up with an imaginary surface, and that happens to be our boundary. I can define another system. For example, I can define only the water in this bottle as my system, not earlier as we defined the complete contents of this bottle. Let me close it so that I don't spill water, and let us say that if I hold it reasonably steadily, there is a surface, top surface of the water, which would be our boundary. Okay. And the other boundaries are the inner surface of the bottle and the bottom, which are in contact with the water, whereas this top surface, top inner surface of the bottle, the cap, etc., are not part of our system boundaries at all. Our system boundaries are the side walls, the bottom walls, and the surface of the water. Remember that here the surface of the water, although physically defined, is flexible. If I tilt it, it changes its location, it changes its size. And also the side boundaries, some of them shrink, some of them expand or get extended. So this gives you an illustration of how flexible the idea of boundaries will be. Okay. It is even possible to define boundaries purely imaginary, in our imagination. For example, I can say, consider in front of me an imaginary box, 10 centimeters this way, 10 centimeters this way, 10 centimeters this way. So we have a box, a cubic box, 10 centimeter by 10 centimeter by 10 centimeter, which is in front of me. I can't see it, but I can imagine it. Start from, say, here, go 10 centimeters this way, 10 centimeters this way. That will define a square of 10 centimeter by 10 centimeter. Consider a height of 10 centimeters, and you have a cube of 10 centimeter by 10 centimeter by 10 centimeter. Okay. So that becomes my system. Here I cannot show the boundaries, but on a drawing or on a sketch, I can show now that my system consists of a cubic region 10 centimeter by 10 centimeter by 10 centimeter. Of course, the other edges would also be there, all 6 surfaces and 12 edges. So this could be my system, a sort of an abstract system, but sometimes such abstract systems are also useful. We have already seen the contents of a bottle. I can sketch it, the cap, and say this is my system. Just to emphasize the boundaries, I will overlay them with dashed or dotted lines. So now this is my system. Now the important thing to remember is system is always defined by its boundaries, and because all the boundaries are defined, one characteristic or the primary characteristic any thermodynamic system will have is its volume. So any system, remember, must have associated with it one property or one characteristic called volume. It may have other characteristics, it may have some mass, it may have some energy, it may have some electric charge, that is okay, but any system must have a volume associated with it. It could be a system as small as a small droplet of water or a small bubble of vapor, or it could be a large system saying whatever is contained in this house or in this room. We will look at other properties of systems later. In fact, what is meant by a property is something which we have yet to define. In this course you will find that we will talk about certain concepts, certain ideas, but define them slightly later. That will usually happen.